All right, so now I got my two servers up so we can get some action out of them. And it was index equal bot speed. Oh, I wanted to search for HTTP. And the way I wanted to do it was to go to data summary and back to source types like we saw before, because you can just click it here, stream HTTP. And that will fill it in the query box in the right format. And now it's finding no events because this is the last 24 hours. So what I want to do is I want to turn on filtering, which is here, sampling, 1 in 1,000, and now all time. And that should get me a reasonable number of events, 24 events of type HTTP. And here they are, and now you can see what HTTP log events look like. They have, of course, a lot of data. And they have familiar things in here like client IP, and here's the content, which is HTML that came from the server, Joomla and such. And what if I can move that over? Guess I can't. Anyway, there we are. And you go down here, you can find the request. Here's the user agent. This is Mozilla. And here's a post to Joomla, and so on. So that's what the kind of thing you'll find. Here's the request. Post something here. And notice, by the way, right away you can see this is a vulnerability scanner, the Accunetrics vulnerability scanner. They got a pirate copy of it. The Accunetrics is a commercial vulnerability scanner, and what those do is, of course, send thousands of packets to a server to find the flaws, and they label every packet so you can tell it's from a real scanner, assuming you are an authorized scan. And in this case, it's the hackers doing it. So right away, we found quite a lot. We found that somebody scanned this thing, and they used this product, and we know where they came from. We know the client IP here this is the web server's IP, and that's something we're going to need later. Let me take some notes here. I'm going to open a note page here. All right, so the web server IP is at that address, 192.168.250.70. The scanner, the Accunetrics scanner IP is the source of this stuff, which is going to be client IP. We saw it up here. It's also down below in source IP that this will do. An address starting in 40. All right, and those are a few facts we learned just by looking at a few packets here. And so a few log entries. So I go back here and get to my instructions. All right, so there we are. If you just look at stream HTTP, we find this information, and all right. And now the name of the server is I'mReallyNotBatman.com. They made this Splunk scenario from a popular movie at the time. And so if you look for stream HTTP, you get a lot of events. If you add this here, this is something Splunk doesn't like you to do. They like you to do this. Field name equals value, because that's efficient on the server. You can also use it like Google and just search for a word, and then it means that word appears anywhere in the event, just like grep. I do it all the time because it gets you the answer, but technically it wastes CPU time, but I don't care. So now it's going to take any event that has this in the name, and of course those will be web requests to our web server, which has that domain name. And I'll sign in, all right. Don't know what's going on there, but there we are. Now I've got it, and here it is scanning. All right, I only found 25 events, but that's at sampling 1 to 1,000. So that means there's 25,000 total events. And let's go here. I did 251 if I was doing one for 100. And so if you just look through them, you will find ones that come from the vulnerability scanner. And so that's several flags. The name of the scanner, the attacker IP, and the web server IP are the first 3 flags, and you can find them all as soon as you find any of the attack packets. And most of the requests to the web server are from the scanner. It sent thousands of requests. And now let's try something. This is where you see the power of Splunk. I want to find the defacement file name. What you can say is there, now in a proper network, you have traffic control, and the server is only a server and never a client. You don't want anybody on the web server opening up a browser and going to websites and downloading things. There's several reasons for that. One of them is they might infect the server. So if you want to put a file on the server, you go to a client machine, download it, scan it, and then move it over to a file share or something. The other, probably more important reason is, as we did in the previous days, when you attack someone, you use a reverse shell. If you do a listening port, the firewall will stop it. The reverse shell, it will phone home from the server to be controlled, and you don't want that happening. And you don't need to allow that. Your server should only be a client. It should be receiving requests and replying. It should never be sending any requests out. There's no need for that, and in a proper network, you don't allow that with rules on your routers and firewalls. So we can see, the question is, did any traffic go backwards on this network? So now that I know the server IP, let's go down here and find the client IP, which is here. If I click on that, there's two different client IPs. I'm just going to choose one. I don't care which one is which, because I just want it to correctly format the query. So here's how I find HTTP traffic with a specified client IP. And now I'm going to put the server's IP in there. So I have that in my, here's the server's IP. So I put that in there, and this is what should never happen. There should never be a request originating from the server. It should be a server and not a client. So I search for that, and I find 0 events, which might seem good, but there's two problems. For one thing, I'm sampling 1 to 1,000, so I better turn that off. And now it takes longer, but I still I'm going to find 0, but the reason I'm finding 0 is I left this in here. If they did a request from the server, it wouldn't be going to my server's domain name. It would be going to some other domain name. So I better not specify that. And this will give me all the HTTP requests that came from the server. And that easily, I found the 8 bad events out of 1,000,000. These are the 8 events that went backwards against traffic. And that's suspicious. That shouldn't be allowed. If it is allowed, nobody should be doing it. There's 9 of them. And now you can just look at these events and see what happened here. If I go to table view, it might, I guess that's not as much fun. Let's take the list view. All right. So here you're seeing binary data come in. And if you just sort of scan through this and look for things you can read, it's some kind of Adobe image going through here. And lots of binary data. And down here, you've got, it's an image JPEG. It is, here's the request. Get, Poison Ivy is coming for you, Batman.jpg. That was the request. This is the response. That's the name of the image they used to deface the web server. And you also know the IP address this came from. So you have quite a few things. This here is the image defacement. That was the image. And you know the IP and you know the server. They'll find that in here. Here's the IP, here's the server address that was used. That's the site. prankglassine.jumpingcrab.com on port 1337. This is very suspicious, running on a strange port. That's the staging server the criminals are using to host malicious things like the image. And we also have the IP address of that, of course. It'll be in here. And I think if I use the expand, one of these there, down it'll put the fields down here. There we are. So now I can see the destination IP. The client IP is the web server, and the destination IP is here. That's the IP address of the staging server holding that thing. So again, this is more useful information. And this is, again, the answer to several flags. So that's the kind of thing you can do here, and there's a whole bunch of flags to find. So the first thing you do is you find the scanning of the web server, and then as you go ahead, I'll demonstrate it probably tomorrow. I'll start doing more. Here you can answer a few. There's a brute force attack. They tried hundreds of passwords to get into the administration panel, and you can find exactly how it worked. And then you can, after they got into the Drupal or the web panel, they uploaded a malicious file, and you can find the file name and see when it ran. And then once they got in, they initiated a ransomware attack. And you can find the source code of the ransomware attack, and you can find it, see it encrypting all the files and model the whole process of it. So it's really very nice. And I think a USB key was involved, and you can get the actual name of the USB key that was inserted that had to do with this. So there's a lot of good stuff. And you can find the process and so on. So it's good practice finding things. That's what Splunk is for. Splunk is for instant response, figuring out what happened, digging through the logs efficiently. And at first it's confusing, but it's not Splunk that's confusing, it's the log data itself that's confusing. And so a little practice, but the main thing is you have to understand Windows and its logs, and the apps and their logs. So give it a try. This is a lot of fun, and I'll demonstrate it in a few stages. But I don't think I need to demonstrate it anymore today, unless you all make a lot of progress in the next bit. But I think it'll just be tomorrow. So that's all for this video.